This is not about those stupid little foot Segway things. Arx Pax makes real, back-to-the-future-style magnetic levitation skateboards. The company gave TechCrunch the first peek inside how their hover engines work, thanks to a special pattern of magnets that could one day power the Hyperloop.
This is version 2 of the Hendo hoverboard, an actual magnetic levitation board. So how does this work?
Yeah, so similar to the Hendo 1.0, we've got our 4 hover engines kind of in the 4 corners. But what's different about this, guy, is we've changed a lot of different things. So probably one of the first things you'll notice is that we have got a skateboard deck interface. So just like in Back to the Future, it's inspired by the skateboard. What would a skateboard hoverboard look like? And this is kind of what we came up with. So we've got the skateboard deck and modified skateboard trucks that attach to the 4 hover engines. So just as you'll shift your weight and kind of the movement that you'll see on a skateboard, you'll get similar movement of the hover engines, but the response is different with hover engines compared to wheels. So as they get closer to the surface, as they're actuated, you'll get some control and directionality out of the hoverboard.
Right, so because they're slightly canted sideways, you can actually get a little bit of traction and kind of push off the ground rather than just being a flat sort of hockey puck sliding around on its own.
Yeah, so yes, exactly. So as we'll see in kind of later demos, as hover engines get closer and increase that magnetic drag, but it's not drag anymore, it's useful. We call it traction, like you were talking about. We can now use that to basically push off the surface and control where we're going.
Now, when we spun this over a conductive surface, nothing happened. There was no lift because there was no change in flux. Victor then went and built all the even arrays, but we shifted 2 magnets so that there was an alternating array. The evens and odds were 2 magnets shifted. These sections that weren't concentric, which is half of the flux, were actually used constructively to generate these eddy currents in the conductive surface. And that gave us a secondary magnetic field which repelled the first, giving us lift, enabling the hoverboard.
So this is what we call the pica. It's basically a small demo unit that you can really get a sense of how a hover engine feels and how it responds to different inputs. So you can turn the switch on the side here, the motor will spin up, and then when you push it down, you'll get a sense of kind of that springiness, how a hover engine responds when I load it. And then when you tilt it, you can feel the bounce. And when you tilt it, you'll get that force. Just as we see in the white box with the hoverboard, you'll really get a sense of when I control that input, how much force do I get out? What does it feel like?
Right, so when you put one of the sides of this motor closer to the flooring, it's going to propel away from that. So you can feel it just sort of skimming around based on just a tiny little change in the direction or angle that it is facing. So when it sits flat, it sits kind of stable, but as soon as you turn it, it's going to fly all over the place.
Yep.
So is this what I think it is? Is this actually a Hyperloop, like a mini Hyperloop?
A mini Hyperloop. So it's not evacuated, that we don't have any vacuum pumps or anything, but we have the tube shape to give you a sense of what could be like. We have our conductive substrate here, in this case aluminum. And we have our hover engine. So this is what we call the Warthog. It's basically a small demonstration unit of a Hyperloop pod. So we've got our 4 hover engines on the ends there, you see. And with small actuations of the hover engines, we can get thrust to send this thing back and forth. And it's actually fairly zippy.
Wow, that's really quick.
Yep. And
so it's just like changing the angle of the motors to shoot around.
You can see it tilt slightly with a small tilt. I think it's less than 5 degrees each way. This thing can zip up and down the tube, and it'll give you enough thrust to do that. So we had this demonstration unit when we were at Texas A&M for the Hyperloop competition a little over a month ago, and teams really got a sense to see, like, okay, if we use Arx Pax's hover engines in our pod design, what would this look like? And so this is kind of just a small demonstration unit, but it had a lot of value for teams to really see what it looked like.
And so how does this go from this size to being like a full-size thing that people and cargo could ride in?
Yeah, so there are a lot of technical challenges with our technology, in addition to just the Hyperloop in general. So operating at high speeds, operating at low pressures, those are new frontiers for us. And we're certainly learning along the way and doing our best to simulate and test. But we're really looking forward to the first test track that SpaceX and the competition is going to provide, because it's going to be a great opportunity for us to see what it's like. We think it should work at high speeds, but really it's we don't have any way to test at 500 miles an hour. So it's really going to be a learning opportunity for us as well.